Hello again, everybody. Thank you for joining us for OmniTestingConf, and welcome to Joao Proença's session, Should We Just Delete It? Joao Proença is a principal quality engineer at Outsystems. Have you ever looked at a failing automated test and asked yourself, should I just delete it? In his talk, you'll learn how to analyze the full lifecycle of an automated test to truly understand its value. During the session, you can ask questions through the Ask a Question button on the right side panel, and after the talk, we'll have a 10-minute Q&A with João where he'll be able to answer all of your questions. And with that, I'll hand it over to our speaker, João.
Hello everyone, my name is João Proença and I come from Lisbon, Portugal, and I am a quality engineer at Outsystems R&D, a provider of low-code platform for web and mobile apps. For the longest time, we've been running thousands and thousands of automated tests as we develop and maintain our product. And I've lost count of the number of times in my career where I've looked at a failing automated test and asked myself, should we just delete it? I guess that a lot of you have been in the same situation, right? We get these questions in our head like, do we even know what we're testing here? Is it relevant? Should we test this so frequently? But then, as soon as you start discussing this idea of deleting the test with someone, you start facing resistance. People are inherently resistant to deleting tests, and I find that baffling, because they're not resistant or as resistant when creating new tests, right? But there are a few things that may explain this. So, before we proceed, let's all just do a quick exercise for a moment, okay? I'm going to ask you to pick the option you prefer out of two. I'm going to present two options. Just think to yourself which one you prefer. Imagine that with option A, you automatically win 900 euros. So 900 euros, no questions asked, they're yours. With option B, there's a small gamble. There's a 90% chance you win 1,000 euros and a 10% chance you win zero. You won't win anything. Out of option A and option B, which one do you prefer? Maybe you already have your decision, right? Well, in this is an example that has been tried out a lot of times in the past, and statistically, 80% of people will go with option A. Okay? Now, let's do a second exercise similar to the first one. Okay? Once again, pick the option you prefer out of option A and B. Now, with option A, you automatically lose 900 euros, so you have to pay 900 out of your pocket. Option B, there's once again a gamble. A 90% chance you lose 1,000 euros and a small 10% chance that you won't lose anything. Which one of these do you prefer this time? Going to give you a little bit of time. Okay. If you follow the statistics, 72% of people will go with option B in this second exercise. But did you notice how similar the two examples were though? In both, you had to choose between a sure thing or a high probability gamble. The mathematical expected value is actually the same. It's 900 in each case. But the big difference is that in the first exercise, you were contemplating on winning those 900 euros, where in the second, you're contemplating on a loss. And that makes us behave completely different. If you follow the statistics and you went with option A in the first exercise and with option B on the second exercise, what you've just experienced is something called loss aversion. It's a known cognitive bias that most of us exhibit in which we experience losses 2 times more intensely than gains. It has been thoroughly studied by Kahneman and Tversky back in the 80s, and they even won the Nobel Prize for this sort of work. One cool fact is that Kahneman was actually the first and ever psychologist to win such an award. And as we can see, we are all much more afraid of losing something than gaining it. And what's important to retain here is that we suffer from this cognitive bias and it really kicks in when we're contemplating on deleting a test. So we must first acknowledge that we're not thinking straight when we're experiencing this loss aversion. But there are other cognitive biases that we all should pay attention to. IKEA effect tells us that we tend to see things we built ourselves as more valuable than they really are. So if we are talking about tests that we actually built, that also kicks in. The sunk cost fallacy that tells us that when we keep on investing time and effort on something because we've already spent a lot of it on it before, then we'll be reluctant in letting that thing go. It's also known as the Concorde fallacy because the French and the British governments kept on investing in the Concorde aircraft even though there were a lot of problems with the project, a lot of accidents and the like. And one very strong one for the leading test is the endowment effect. People are more likely to retain an object they already own than acquire that same object when they do not own it already. And this one is really powerful. When you look at a failing automated test, you should ask yourself, if I didn't have this test already, would I be creating it tomorrow? Or would I be doing something different? Now, if we consider all of these biases that most of us exhibit, of course we're going to be naturally resistant when we are about to press the delete button. So how can we challenge this resistance in our heads and in our peer sets? How do we overcome our cognitive biases and think straight about this? Well, first, just a small disclaimer, this is hard stuff, deciding to delete a test or not. And by no means I am here trying to tell you that I know it all. What I'm presenting here is what worked for me in my experience in the past, and I'm trying to provide you with ideas on how to go about this in a rational way. And some of them may even be a bit controversial for some, but please take into account that we all come from different contexts, and that what may work for me maybe doesn't work for you, but maybe some of the ideas are applicable in a different way. Is that fair enough? I hope so. Okay, so for me, thinking rationally about deleting a test is mostly about evaluating the cost versus the value of the test. And in automated tests, this mostly means assessing the risk being covered versus the total cost of ownership of the test. Let's go a bit deeper into each one of these two. A lot of times in my career, I've seen people stating this: I don't want to lower our test coverage, which if you press more on it, usually you get something like, don't worry about the leading tests, worry about the tests that we don't have, It's just one more test, what's the problem? Well, the problem can actually be total cost of ownership, to be more precise. What do I mean by this? Usually when people think about the costs of an automated test, they will only think about how much it costs to develop a test. What's the effort involved in that? But that cost a lot of times pales in comparison to other costs like running and maintaining the test. If you put all of these together, these end up forming the total cost of ownership of the test. Now, let's go a bit deeper into each one of these. Development, of course, I'm not going to talk a lot about that. That's just the time that we take in developing a new test. But let's look about on running the test. First, of course, you have an infrastructure cost. Back in the day, this usually meant having our own servers busy running tests. Nowadays, a lot of us use services such as AWS and Azure, the cloud, to run tests on a daily basis. And of course, those amount to a monetary cost that can be quite significant, but you can actually measure with precision. But that's not the only cost you have when running the test. It's easy to think that the more automated tests you have, the better, but reality is a bit more complex than that. At the company where I work, we learned this by experience. 10 years ago, CI/CD wasn't mainstream yet, but we already had these in-house servers that ran automated tests overnight. What was once a set of tests that could be run during the night, people would come in the morning and look at the results, after a while became bigger. And maybe you would come in the morning and you wouldn't see the results. You had to wait until lunchtime to have all the whole of the test set with outputs for you to analyze. After a while, after a few years, we got into a situation where we couldn't run those tests in 24 hours. And for a developer trying to validate their changes into the code, this is a horrible place to be in. Why? Well, in the Continuous Testing for DevOps Professionals book, there's a study, an interesting study conducted where they analyze how the time it takes to fix a bug grows with how long that bug takes to be detected once it has been put into the code. As you can see, if it takes like 1 hour to fix a bug you detected the same day it was introduced in the code, that same bug will most times require 8 hours of work if it is only detected at the end of the sprint, so 2 weeks up front. So And this time can even grow larger if you only detect it in production like a month later or whatever. So if we are only discovering bugs after 1 or 2 days or even more, then the time spent fixing those problems also increases. This is the idea that we get from this. Later on, DevOps principles became mainstream at my company, and we started introducing CI/CD pipelines and became really obsessed with making feedback loops as short as possible because we acknowledge the importance of having these feedback loops short. You want to find bugs the same day you cause them, so with all the code commits that are happening, you want to keep the feedback loop of your test automation under 1 hour or less, for instance, just as an example. Now imagine you're considering deleting a test. If that test takes like 10 milliseconds to run, a low-level unit test, sure, it's not taking a lot of time. But if it takes like 1 second, then you can only have like 3,600 of those tests inside a 1 hour time span. If it takes a minute to run, like it's a UI test, a big end-to-end test that does a lot of stuff, that's a very expensive test. You can only fit 60 of those tests inside a 1 hour feedback loop. And note one thing, I know that this is just a simplified way of looking at test automation in pipelines, just in order to pass my idea. Of course that you can consider parallel processing of tests in these CI/CD pipelines using a lot of servers, but in most contexts, I believe that there's always so far as you can go, and you always reach a limit in which you can't add any more tests without making the feedback loop longer as well. And this comparison between the tests that you're running versus the tests that you could be running is very important. It's something called the opportunity cost of the test. In general terms, what this means is that you're giving up on the benefit of something else by making a specific investment. In this case, you're investing in the specific test that can be really costly when you could, and that you may delete, instead of investing in other tests, better tests that you might be running. Now, we've covered the time cost of running the tests in our infrastructure, but let's now go into what it costs in people's time, maintaining the test. As I've said before, a lot of times engineering teams only consider the effort needed to build the test, but then underestimate the effort of maintaining the test. And this is mostly a people cost, as I was saying. If a test fails, someone will probably invest some effort in dealing with that failure. A tester, an automation engineer. In my case, we do whole team approach to testing, so a lot of times it's developers. It depends on the way you're running your organization. That effort will be divided in 1, understanding what is being tested, 2, understanding why the test is failing, and 3, finally fixing the test. Let's think a bit about each one of these phases. Now, what is being tested? If you look at this first one, sometimes people won't even bother understanding what is being tested and just skip to the reason why the test is failing and attack item number 2. And sometimes I have even seen tests that no one really knows what they're testing exactly. And this, in my experience, is a problem. Trying to delete a test, there's this rule. The less we know about a test, the more reluctant we will be about deleting it. Recently, I had a situation where I was considering deleting a test, but some colleagues of mine weren't comfortable with the possibility. So I asked them, what does the test do exactly? Why are you so resistant to the idea of deleting this test? And they were, well, I'm not sure exactly what it does, but it does stuff in this area, which is really risky in our product, and I've seen that test find bugs before. And of course, these are valid arguments, but I wanted to go deeper into the test. So I started analyzing the tests and to just let me understand the goal of the test. And I figured out that it was trying to test a combination of features that wasn't possible in the system anymore for a couple of years. So it was testing something that actually didn't make sense anymore. This is why tests must be clear regarding their goals, the scenarios that are being covered. If a test is really obscure, people will tend to only deal with their failures rather than dealing with the nature of the test itself. Now, these sorts of obscure tests usually are high-level, big, end-to-end tests that do a lot of stuff. The thing here was my colleagues were only valuing that test because it had made them find bugs in the past. But those bugs are only discovered because one of the many things that are being exercised throughout starts behaving differently, not because the test is testing that bug specifically. So what we can start by doing is to figure out exactly what were those bugs and look for redundancy. As software evolves, you may find that most of the risk is already being covered by other tests. Or if they don't exist, you can just create smaller, lower level tests that cover them and then reevaluate if having such a complex test around makes sense anymore. A lot of times it won't. For this analysis, it's really very valuable to have detailed data about past test runs. For instance, coming from a test management solution that lets you understand which bugs were unearthed in the past from previous runs of that specific test. Never forget that you should avoid having end-to-end tests that are covering stuff that should be tested at the unit or integration level. Now, of course, it's important to understand what the test is doing, but once you understand what it's doing, you need to go into figuring out why the test is failing. And there can be a number of reasons for that. Sometimes tests fail because bugs are found, and that's awesome. That's exactly what they exist for. But sometimes it's some other thing. Tests can be flaky, and even if you improve them a few times, they still show some flakiness, and it's a real hassle. Sometimes you need to accept a new result because the behavior of the sims changed legitimately and you're comparing against a golden master or something like that, and you just need to readjust the golden master. Sometimes it's only the test automation that it's broken. For example, if you're doing UI testing and you evolve the UI of your application, the UI tests may start failing, but nothing is wrong because you just changed the UI and you need to readjust the automation. It's just something that you need to do. The bottom line is, in all of those situations, there will be disruption for you and your team, and you need to do something about fixing the tasks afterwards. Now, if we think about all of these parts of maintaining tests and go back to an idea I expressed earlier, we tend to think of the cost of an automated test as being how much it costs to build it. Let's look at an extreme case, okay? Imagine that we built an automated test in 4 hours, but maybe we cut some corners to be able to do it quickly. The test is not really clear on its purpose, and it's not that sturdy. What if that test fails twice every month, and between understanding what is being done, what it does, why it is failing, and fixing it, someone looking at the test uses about 2 hours to sort things out. So 2 hours with 2 times per month, 4 hours per month. After a year, that amounts to basically 48 hours out of someone's time. If the test lays around for 5 years, which I've seen happening, that's actually 240 hours of that were spent by someone just looking and fixing those tests. That's more than a month of someone working on that they could be working on something else. Wouldn't you rather invest that time in some better tests instead of the flaky end-to-end one? Once again, it's really useful to have in place test management systems that allow you to understand how many times a test fails, not because of a bug, but other reasons, and how much effort is spent in fixing it. Now, I've been talking about total cost of ownership, but let's not forget about the other part of the equation. As I've said before, you have to evaluate both the cost of having tests, but also the value that the tests give you. And the value here, for me, is all about the risk that we are covering with the tests. A risk in software engineering is a potential problem that may or not happen in the future. Risks may be evaluated according to the impact of the potential problem versus the probability of such a problem occurring. You use tests to assert that the problem is not happening and get peace of mind. The thing with probability here is that it doesn't necessarily stay the same over time. What do I mean by this? Let's, for example, considering a defect escape. A defect was detected in our software in production, someone fixed it, and in the process they created a test to make sure that the defect wouldn't come back. And this is like a healthy practice in our industry, right? But if that happened like 5 years ago and the bug never resurfaced, then does the test still make sense? Once again, for this sort of analysis, it's really important to have detailed historical data of your test runs that allows you to verify which bugs were unearthed or not by your tests over time. Another reason for probability changing is the way technology evolves. I've seen a bunch of tests that were made a long time ago to ensure that the same front-end feature would work correctly in all major browsers. But nowadays, the most popular browsers are much more similar in nature and adhere to the same standards. So does it still make sense to test the same thing for Internet Explorer, Safari, Chrome, etc.? Maybe not, because a lot of those browsers have the same underlying technologies. Also, the probability of something bad happening can change with the evolution of the feature being tested. Of course, that when you're not going to delete tests for a feature you've just built, because maybe you're going to see some changes or there are known bugs still to be found and fixes will be introduced. So those tests will be really important in your near future. But after the feature has matured, a lot of things can change. Features can slowly get replaced by other features. Features can maybe not be used or as much or at all, or they become like completely stable and there are no plans to change them anymore. This is also one of those analyses that we can do where having data around feature usage and code commit frequency over that specific area of the code that pertains to the feature is very useful. It allows you to reevaluate the new probability of something bad happening once you have a test and a feature laying around for a long time. Going back to what the risk entails, it's also important to look at the impact of a potential problem, not just the probability. What would be the outcome for our users should the problem arise? This really requires you to put yourself in the shoes of the users and distinguish between something which is only an annoyance or something that completely kills a core use case of your software. If something is low probability, low impact, it's probably easy to conclude that the test can be deleted, But if the impact is serious, even with a low probability, then the evaluation is a bit more complicated. Maybe the test should stick around, or maybe you can consider alternatives if the cost of the test is really high. You can try to address the potential impact, for instance. So you can set up effective monitoring and a disaster control plan if the problem arises. So if we imagine that the potential impact is, for instance, the service going down, and put in place procedures and mechanisms that allow us to quickly understand that sort of thing is happening and react to it, like reverting to a previous version instance instantly, and maybe fire up the service again, then we know the problem will happen just for a short while, and thus the impact becomes much smaller. It's about reacting fast to the impact rather than paying a high cost for having certain tests around preventing that risk. One other alternative that we are really big fans over at Outsystems is in our quality strategy is called dogfooding. In case you don't know, dogfooding is when a company uses its own product internally. At my company, we do this a lot. A lot of our internal applications are built with our own technology. So for instance, whenever I'm submitting vacations, doing performance reviews, or even checking CI/CD results, I'm doing that through an Outsystems app. This dogfooding is a risk mitigation strategy that is a part of our release process. Of course that we have a lot of test automation in place to find bugs quickly, but then we first release these new versions of our software to our internal teams first, working in these internal apps, and only later do we release them to the rest of the world, to our customers. And a lot of times we catch these low probability, high impact problems in this dogfooding stage, which makes their impact much smaller because it's only affecting us internally, and we can react quickly because it's all happening in-house. We can sit next to the people that are experiencing it and just have a better troubleshooting of the problems themselves. And to be honest, there have been a number of situations when we deleted an old test, because we were pretty confident that if by any chance the behavior being tested gets broken, we will find out about it internally through these teams. Now, as a wrap up, because I've covered a lot of stuff, I'd like to recall some few key pointers here, okay? So deleting tests, first acknowledge our cognitive biases, especially loss aversion and the endowment effect. Acknowledge that you may suffer from them, but other people as well, and take that to account when you're having an informed discussion about deleting a test. After acknowledging that, it's all about evaluating the risk that is being covered by the test versus the total cost of ownership of that test. So you can even write a report of sorts where you make these clear to anyone who wants to understand your reasoning if the risk is high or low, and if the total cost of ownership is high or low as well. For the total cost of ownership, detail what's the cost of running the test, not just developing the test, but also the cost of running the test, which is an infrastructure cost, plus the impact on the feedback loop in your automated strategy. Also detail what's the cost of maintaining the test in terms of people, How many times does the test fail per month? How many of those times is because of a real bug? How much time do people take correcting those failures? If you have historical data to back this up, that's awesome. If not, just go with what people can tell you. Use all of these considerations to classify if the TCO is high or low for this specific test. Then for the impact, the covered risk, remember it's about impact and probability. Classify the probability of something bad happening. Remember to take into consideration how much the feature under test is being used, if it's old or if it's being actively changed, if it was a defect escape as it surfaced again, also very important as the probabilities change since the test was created. As for the impact, you should determine what is the worst that can happen for users and in case the test breaks, the thing that's being tested breaks. And finally, don't ever forget about the alternatives to the test. There might be redundancy, maybe the risk is already being covered by other tests, or maybe you can refactor the test that you have in order for it to be better, more sturdier and faster, or think about dogfooding and alternative release strategies to mitigate risks in different ways. And once you have this evaluation done, the covered risk versus the total cost of ownership as being high or low, then there's a really simple matrix to go about your decision. If you have a high risk and a low cost for the specific test, that's usually a keeper. There's a no-brainer there. Also a no-brainer when you evaluate a test as being something with low risk but with a high cost. Those are the ones that usually you want to delete. When you go into the area of something which is high risk and high cost, then this is usually when you want to do something about it. You could look at the redundancy if the risk being covered by the test is also already being covered by other tests. Maybe you want to refactor the test, which will kind of push the test into the high risk, low cost area by lowering the cost that you're getting from the test by having better, smaller, sturdier tests. Or you can consider the alternatives to the test that allow you to delete the test, basically lowering the risk, lowering the impact of something bad happening, and getting rid of the cost, so you just delete it. When you go into the low risk, low cost area of the matrix, this is really up to you. In our experience, we tend to delete these tests as well because even though something is low risk, low cost, you can just leave them laying around. But after a while, you can have a lot of these low cost tests that pile up into a significant amount of cost. And for us, it's just better to get rid of them. But even if you don't perfectly justify that a test, even if you perfectly justify that a test should be deleted, sometimes you get faced with someone that reacting like this. What if we don't catch a bug because the test was deleted or its other form? This test might come in handy one day. I'm afraid of deleting it. Well, this is the same reason why we keep useless stuff in your basement or your garage, It's a perfect manifestation of the endowment effect. Once you have something, you resist getting rid of it. It may come in handy one day and you never know. And if you're facing this situation and in all else fails, you can always just go, okay, we can keep this, but it stays in the garage, I don't want to see this in the house, which for a test means, okay, let's not delete the test, but let's disable it for a while and see what happens. Let's just not run it and take the risk for a couple of releases. And after a while, maybe you'll find that people will start feeling that they really don't miss that test. And it's much easier for them to hit the delete button with confidence. Thank you so much. Please let me know if you have any questions.